All right, guys, let's talk about simplifying expressions. And we're going to be utilizing a little bit of the distributive property here as well, and talking about combining some like terms and how to pick those out. So let's get started. So I got an expression written out here. Let's scan through here and see what we got first. That's always the safest thing to do. So if we notice, hopefully we got some distributive property going on here, right? That -5 is being multiplied by that quantity. So these two terms are attached by multiplication, so that makes this one big term. And we've got a constant term here and a variable term here. So let's go ahead and expand this out. So let's go ahead and send this guy through by multiplying. And by the way, that's a y, right? It's a -y. That's the same thing as saying a -1. So I like to throw that in there sometimes just so I don't accidentally forget that there's a 1y there. It's actually a -1y. Let's go ahead and do that. So -5 times +3, that's going to give us a -15 constants. And we got a -5 times a -1y, that's going to give us a +5y, and that's a variable term. And then we're just going to go ahead and have to carry these down, that +20 and that -8y, just going to come down into our next steps there. Now, slide this up. Now we can identify and combine any like terms that we have. So we've got a y term and a y term, so those two terms are alike. So if we pull them out and slide them together, right, and remember the signs to the left of the terms, so that positive sign with him, that negative sign with this guy, go with the terms, okay? So when we pull them out and slide them together, that creates the expression +5 minus 8. So if we just take 5 minus 8 there, that's going to give us a -3, but they are y terms, so -3y's. And let's see here, we got a constant term, right? The sign to the left of the term goes with it. Constant term here. So if we pull them out, slide them together, that's going to turn into -15 plus 20, which is going to give us a +5. And there's our answer. That's as far as we can go. And just to make sure that you notice, there is another answer to this. If we use the commutative property here, right, we could switch those two terms and we could get another answer that looks like that. So if this was our multiple choice test or something like that, either one of these answers could be given to you, and they are both equivalent to each other. They're the same answers. They just look a little bit different. Let's try another one. Now, this is a common problem that a lot of people mess up because of the weird distributive property going on here. A lot of people will not notice this because there's no number outside of this parenthesis, but really there is. There's really always a 1 there, and especially since this negative sign is here, we really have to take a look at that -1 being there. So let's go ahead and distribute that through. That 3t is just going to come on down. That 3t is not a part of that distributive process. But the -1 is, okay? So I'm not going to put that sign here yet, right? That sign goes with the 1 when I send it through for the distribution, right? So that 1 goes to the times +4t, and then that's going to give us a -4t. Okay, and then that -1 is going to be multiplied by the -7, which is going to give us a +7, right? And then we'll just go ahead and bring down that -12 and that +6t. Now we can identify our like terms. So let's run through here. We got a t term, another t term, another t term. So if we pull all three of those terms down and slide them together, that's going to turn into the expression 3 minus 4 plus 6. And those are t terms, right? So 3 minus 4 gives us -1 t's, and then -1 plus 6 gives us +5 t's. Okay, and then we got constant here, and another constant here. If we pull them out, slide them together, that turns into the expression 7 minus 12, which gives us a -5. And that's as far as we can go. 5t minus 5, or we could say -5 plus 5t. And that is as far as we can go. These two answers are equivalent to each other. And there you go. So we did some distributive property combined with some combining like terms. Hope that helps.